In example 3.1.6, we're looking at the sampling distribution of the sample proportion. So if I have a population and I'm looking at categorical data and I take samples from it and I find a bunch of the p-hats, what are those going to look like? So we go to proportion under sampling distributions in StatKey, and we're going to use the Hollywood Movie 2E action data. We'll see that the actual population proportion, which we'd call P, is 0.24. And what we want to look at is what happens when we generate samples of different sizes and plot out what the p-hats look like for those samples using sizes 5, 20, and 50, and 3,000 samples of each size. So if we go over to StatKey and we click on proportion and we put in the data set Hollywood Movies 2E action, we can see in the side that we have a population proportion of 0.240. So the first thing we want to do is draw samples of size 5, and we want 3,000 of them. So I'll click generate 1,000 samples 3 times. And so what's plotted here, they just kind of look like bars, but it's a whole bunch of dots that make long bars of what the p-hats look like. And so what we're seeing for our values of p-hat is that we took 3,000 samples. The average of the 3,000 p-hats is 0.241, so that's close to the original 0.24, and we have a standard error of 0.192. If we had to classify this graph, we would say it's skewed to the right because we have more of a peak on the left side with a trailing off to the right. If we change our sample size then to be 20, and we again generate 1, 2, 3. What we're seeing is that they're centered. The 3,000 p-hats are centered at 0.239, which is again close to 0.24, and our standard error has dropped down to 0.093. So we have less variability here than we had in the last one with samples of size 5. And we are losing some of that skew. We have a very slight tail to the right, but this is more or less symmetric. Finally, if we bump up to a sample size of 50 and do the same thing, we are going to look at the center being at 0.240, so right at the original population P of 0.24, and our standard error has decreased again to 0.058. So if you would put these 3 plots that we looked at side by side, you'll see that the spread in the first plot was the greatest and the spread in this one is the least. So we are less variable in the p-hats we get as we take bigger sample sizes. And then also this plot looks symmetric. So as we are taking bigger sample sizes, we're not only reducing the standard error that we're seeing or the spread that we're seeing in the p-hats, but they start to look more symmetric as we go. In all cases, they were centered at the population value of 0.24.